Hi guys, I'm a little bit excited about this one because what I want to do is teach you roughly how to approach dividing by two-digit numbers, and this comes up probably more as you go higher up in the school. So I aim most of my videos at around about year 5 or 6 kids. This sort of thing would probably happen in intermediate a little bit more, so for 11 and 12-year-olds. But there's some things we can learn about maths along the way. Before we start though, we're going to need to know some basic things. So here are a collection of things you'll need in your toolbox before you start. Basic Facts 212, that's your times tables, right? And if you've seen any of my videos, I always encourage you to learn your times tables. It really simplifies any maths that you do. Know what factors are. Factors are the numbers that make up the number that you are talking about. For example, if you go 3 times 4, those are the factors of 12. Okay, so when we're talking about the factors, the numbers that you can multiply to make that number there. It changes for every number. Some of them have more. 12 has more than just 3 times 4. It also has 2 times 6 and 1 times 12. So, see prime numbers. Now this is a big bit of understanding. Prime numbers only have 2 factors, 1 and themselves. For example, 13. You can't divide it up any other way. So that's called a prime number. And I won't go through them all now, but if you can look up separately what prime numbers are if you don't quite understand, it's a fundamental understanding for this kind of thing that we're going to be doing. Then the last one is understand estimation. Now, estimation is another word for guessing or having a rule of thumb. So if I was to say 49, I can round that up to roughly 50. I can estimate that it's nearly 50, and I can use that, as my old physics teacher used to say, as my bucket maths. I can say 49 is nearly 50. Now if I think about it like that, I can guess how many times it'll fit into another number. So these are all worth a lesson each by themselves, and hopefully you've had some of that already. If you haven't, you may not be quite ready for this set of strategies that I'm going to show you now. But if you do not have these, make sure that you get them. They're really handy strategies for dealing with numbers and understanding how numbers work all together. Alright, so let's have a look at the start of our next thing. I'll just pause you for a while there. Okay, so the first thing you might want to do with your question, if you are dividing by a double-digit number, is it's really important to establish what kind of number it is, because that will determine the best, most efficient strategy that we can use to find the answer. If it's 11 or 12, we can use our standard quick formula that I've shown you before. It's very easy, and we'll go through that in a second. If it's a tidy number, for example, say 40 or 50, there's a very quick way we can divide by that, and I'll show you how that works in a second. We'll go through them step by step. Or if it's a number with factors, strangely that makes it easier. So for example, if you had 63 that you were trying to divide by, you can see that 63 is made up of 7 times 9. 7 times 9 is 63. So these are the factors of it. So I'll show you how that works when we get to it. And then prime numbers. Say for example, it's 19. 19 is a prime number. It can only be divided by 1 and itself. How do we deal with that when we come to a bigger strategy? And so what I want to do is show you these 4 steps and see if that helps you out. So let's begin. Right, I just want to very quickly go over these two because it's the same strategy I've shown you many times before. The difference here is really that instead of just dealing with one number at a time, we deal with two. And it's just as easy really. So the first question I'm going to ask myself is, how many times does 11 fit into 86? It's nearly 88, which would be 8 times. But it doesn't quite fit, so it's going to fit 7 times, and I've got something left over. Now 7 times 11 is 77. If I work up from 77 to 86, I get 3 plus 6, which is 9. I'll put my 9 down there. So it works in exactly the same fashion, except that I start with 2 numbers. Then, how many times does 11 fit into 97? Again, not quite 99, so it must only fit 8 times. So 88 to 97 gives me a remainder of 9, and oh, look at that, 11 into 99 fits exactly 9 times. So that one fits neatly. Will it still work if there's decimals or if there's a remainder on the end? Absolutely it will. It's the same strategy. Then moving quickly on to divided by 12. It's exactly the same process. Now, in this case, I'm going to have to go to the first 3 numbers because you can see here 12 does not fit into 11 even. So I'm going to think about, well, how many times does 12 fit into 115, as if that was 100. It's actually 115 hundreds, so we'll work with that for the moment. How many times does it fit in? Well, the closest is 108, which if my memory serves is 9 times. Then all I've got to do is figure it out. I know 9 times 12 is 108, 2 to 110 plus 5 leaves me 7. Then I'm thinking about 75. In the 12 times table, thinking about your multiples, the closest there is 72, which would give me 6 times with 3 left over. Then, how many times does 12 fit into 36? Easy, fits in 3 times. So from that, 11,556 divided by 12, I get 963. My estimation is that's about right. If I had nearly 1,000 times 12, I would have nearly 12,000. So that's where some of the estimation comes in, making sure your answer makes sense. All right, this is the easy one. Well, one of the easy ones. In my opinion, they're all not too bad once you break them down into little bits. So let's have a look at tidy numbers. Now you might be asking yourself, why do tidy numbers get their own special mention? It's because they're especially easy. What I would suggest you do, say you've got a 50 or a 30, 80, whatever it is that you've been asked to divide the number by, you can just ignore the 0, this placeholder to make that 50 in the meantime. What I would suggest that you do is, first of all, divide this by 5 and then divide the whole lot again by 10, which is the strategy we're going to use next, but it's even simpler because we're dividing by 10. So for example, how many times does 5, just thinking about the 5, don't worry about 50 at the moment, fit into 38? 35 is the closest, so that's 7 times. That leaves us 3 left over. Then 50 not 50, 5 goes into 39, 7 times again, that's 35, 5 times 7 is 35, set with 4 left over. Then we've got 5 into 45 gives us 9. In this case there's no remainder. That's very handy and tidy. Now, it's not our final answer. All we've done is divide it by 5. Now, remember, there's this imaginary decimal point here and a bunch of zeros afterwards. To divide this by 10 again, it's very simple. Pop our decimal point in between those. We've shifted the number across. Now a decimal appears instead of here, here. So 3,895 divided by 50 is 77.9. So what we've done is we've broken it down into dividing by 5 and then very simply dividing by 10. Now, have a go at this one down here. I'll just move it up slightly so you can see it better by yourself and see what you come up with. I'll just remain quiet for a moment. You can pause it, have a crack at it. Divide by 3 first, then divide by 10. Okay, so let's have a look. How many times does 3 go into 2? It doesn't, so we can just ignore that for the moment and make that 28. Or you could just look at that whole thing as 28. How many times does 3 go into 28? Oh, it's nearly 30. 27 is the closest. That must be 9 times. Then, how many have I got left over? Just 1. How many times does 3 fit into 15? Exactly 5 times. That's handy. How many times does 3 fit into 3? 1 time. How many times does 3 fit into 0? Well, no times. Then, we haven't quite finished. Remember, we're dividing by 30. All we have to do is imagine our decimal point there, pop him over there, make sure he's in. Our new answer for 28,530 divided by 30 is 951. That was just handy that that 0 was there. We could just ignore that altogether. So hopefully that's a handy trick that you can do. It's just breaking it down one step further from your regular algorithm, finding your answer with just that number, then dividing it by 10 again. Okay, so now we get into the juicy bits. We will start learning how to divide by non-primes, numbers that don't fall into the prime number category, sometimes called composite numbers, but basically any number that has more than just the 2 factors to it. So in this case I'm going to start with 63 just because it's an interesting number and I like it. Now, you might recognize 63 from the 9 times table. That's going to help us. So in your head you might think something like, you don't have to write this down yet, but you know that 63 is made by 7 times 9 or 9 times 7, whichever floats your boat. That's going to help us in a second, and I'll show you why, because we're going to solve this problem that looks really hard with a very, very quick process. Now, if you look this up on YouTube, you'll find people who show you how to do this sort of thing with a very long-winded thing that goes right down the page. My way of thinking is, give this job to a lazy person and they'll figure out the quickest possible way to do it. And it might work a bit like this. So I'll just copy the number out again for the sake of simplicity. So it's 28,476. And the first thing I'm going to do is divide that by 7. Now, why am I dividing that whole thing by 7? I'll show you in a second. It's like a 2-step thing. In the same way when we were dividing by tidy numbers and you could divide by 5 first and then divide by 10, we're doing the exact same thing here, except that we're using the factors of 7 and 9 to do it instead. So it's the same process, except that we're going to have to do one more actual calculation to get to our final answer. We've split it up. So we divide the whole number with our first factor first. Okay, so let's see if I can get this right. So 7 goes into 28 happily, exactly 4 times there, so that's nice and easy. Nothing to carry over there. Then it does not fit into 4, so I can put a 0 there, but I'll just put that aside there. Now we're thinking it's 47. So how many times can we fit it into 47? Well, let's see. 7 times 6 is 42, isn't it? 49 would be 7 times 7, so it can't be that one, must be the one below it, 42, so we put a 6 there. And we've got 5 left over. and 7 fits into 56. Oh, exactly 8 times. That's handy. 7 times 8 is 56. Oh, that's very convenient. So that's only the first part of our thing. Now here's the thing, that's what the little trick that I'm going to show you that I hope will work for you. I've got this new number here, 4068. I've already divided my whole thing by 7. Now to get my final answer, I'm going to divide this by 9, and it's something I call a double-decker division. And all I've done is I've split 63 into 9 and 7 and figured it out that way. So 9 into 40, well 9 into 4 doesn't fit, but it does fit into 40. It fits 4 times. 9 times 4 is 36, and I've got 4 left over, so I sneak my 4 down there. 9 fits into 45, not quite 46, but close, and that is 5 times. And I've got 1 left over. Oh, what do you know? 9 fits into 18 exactly twice. So my answer to 28,476 divided by 63 is going to be 452. Now, some of you will be saying, that doesn't look right, Mr. M. How on earth can that be true by splitting it up? Well, you know, as we did with the 5s and the 10s, this is exactly the same thing. Just looks a wee bit trickier because we've sandwiched all those numbers together, but actually the process isn't any more difficult than any of the algorithms that you've been taught to do before. It's just remembering that you've got a 2-step process to do it with. Double check, you say. Well, alright then, let's see. We had, are we still in focus there? Yep, good. So we had 28,476, and we went on to divide it by 63. 452, what do you know? We got the right answer. Now, looking at me use the calculator there, you'll say, why didn't you just do that in the first place? This is about problem solving. Sometimes you're in a situation where you just don't have a calculator, you don't have a phone. I would like to think that you have a way of thinking about it. Now, you may not ever come across a problem exactly like this, but there might be one similar. Right, I'm going to write up another one for you, and we'll see how you go with it. Okay, here's our new question. Now, we can tell pretty much straight away, because 25 is a multiple of 5. It is not going to fit neatly into this. There's going to be a remainder of some kind, which we can turn into a decimal later. But our process isn't going to change. We know that there's going to be a messy bit at the end. That's okay. That's not a problem. What is 25 made of? Well, it's the square of 5, isn't it? So it's going to be the same as 5 times 5. Now remember, you don't have to write this down. This is something that can happen in your head. You might just recognize 25 from the 5 times table. So we're going to use the same process. Now weirdly, we're going to divide by 5 twice, but the thing that we divide by is going to change slightly. So we'll start here, won't we? Then we'll say, alright then, well, 30, we're going to look straight at 37. We won't even bother saying it doesn't fit into 3, that's obvious. 35 is the closest thing we have there, so 5 fits into 35 7 times, and we've got 2 left over, which goes right next to that 6 there. You'll say, well, that's handy because 5 times 5 is 25, so the 5 goes there, and I've got 1 left over there. Which then of course means I've got 18, closest under 18 is 15, which is 3 times 5, and I've got a little bit left over, so we'll just give ourselves some space there. 18 take away 15 is 3, so I sneak that up there, it's like 30 tenths, isn't it? Happily, 5 fits neatly into 36 times, so we can say the first part of our question is 753.6. Am I still on the screen there? Oh yeah, good. I might just... Oh no, you can fit. Then, what we're going to do is the next stage of it actually I will move that over slightly so you can sort of see where I'm going with it. We want to divide it by 5 again, because 5 times 5 is 25. We want to get our ultimate answer. So we're going to do the same thing again. We're going to divide this all by 5. Now, 5 fits into 7 once with 2 left over. 5 fits neatly into 25 5 times. 5 does not fit into 3. Make sure I get my decimal there. Put that across there. 5 fits into 36 7 times with 1 left over. And then 5 fits into 10 hundredths 2 times. So, if you got for your answer 3,768 divided by 25 is 150.72, you are correct. Actually, it's kind of fun. I love this sort of thing. It's very sort of problem-solving and an interesting way to deal with maths. You know, making a bit of a mess on the page, but that's what interesting maths is all about. All right. Would you be keen on trying one for yourself? See how you go. All right. I'll just set one up for you. All right. What do you think about this one? 6,910.4 divided by 56. My end number is going to be relatively small because 6,000 isn't that much, nearly 7,000. My estimation is it's probably going to be 100 and something, roughly speaking. So that's where estimation comes into it, for this part of it anyway. As usual, we need to think of the 2 factors that could make 56. The one that springs to mind, the one that seems obvious, is to go, it's the same as 7 times 8. 7 times 8 is 56. One of my personal favourite times tables, just by the way. So we could start with the 7 or we could start with the 8, whichever floats your boat. It doesn't matter which one you choose. I'm going to start with the 8, just because I like it. Then 8 fits into, well, it doesn't fit into 6, but it does fit into 69, 69 hundreds in this case. 8 times 8 is 64, so 8 is the closest there, which leaves us 5 to play with here. 6 times 8 is 48, which is the number under this one, so we can say 6 goes there. Then from 48 to 51 is just 3. Doesn't quite make 32, which would be a neat 3 times. So the next one under that, of course, is 24, which is 3 times. 24 to 30 is 6. And what do we have there? What's our closest one there? So we had 56 was 7 times, and it fits in neatly, exactly 8 times, doesn't it? That makes sense. 8 times 8 is 64. We knew that. That's the one we did there. Must be late at night, Mr. Ian, getting a bit tired. Now, our next step then was to divide using our other factor, 7 there. 7 into 8 goes once, that's easy. Then my leftover one there, 16. 7 into 16, well, fits twice into 14 with 2 left over. Fits 3 times into 23. 3 times 7 is 21, but I've got 2 left over. And then, don't forget the decimal, really important not to forget that. 7 fits into 28. Oh, exactly 4 times. Oh, so it doesn't look very likely because I'm dividing all of this by 56, but you end up with the same decimal here, but that's just a in this case a coincidence. So my answer to 6,910.4 divided by 56 would be 123.4. Ah, how about that? Who thought that you'd be able to do this kind of maths on a piece of paper by the end of this session? If you've had a go and if you got the right answer, you're doing extremely well, guys. If you ended up with a wrong digit, just double check and make sure that your basic facts are right. Often where I find kids get a bit confused is when they're adding up from the number to find their remainders. That's often the thing that traps them. And you do have to focus on that. It is easy to lose track. I find getting the remainders by adding on to the smaller number until you get to the larger one is easier. So for this one, it was 48 to 51. 48 to 50 is 3 plus 1 is 3. And that was an easier way to do it than trying to subtract. Alright, I think we've covered that one. The next one is a little bit trickier because we're going to talk about primes, and they're going to use a lot of estimation. How does the splitting up strategy, the double-decker division if you like, actually work? Well, let's have a look at a much simpler equation and see if we can sort of help it make sense for you. So for example, I've got 12 of these little Lego blocks here, and I want to divide them into 6 parts. Now we know the answer is 2. That's our result that we know we're going to get. But I just want to show you how it works in that strategy so that you can see how it works with larger numbers as well. So 12 divided by 6 is very simple. We know it's 2, so that's our end result. But what does it look like when we're chopping this up here? So we've got 12 here. You can count them if you like, but trust me, there's 12. So I know that 6 is made up of 3 times 2. 2 and 3 are factors of 6. Oh, that's pretty easy to understand. Alright, so what I'm going to do first then is divide this into 3. I can use equal sharing for that. That makes it easy. I'll make 3 sets. And you pretty much guess how that's going to look. Making sure each set's got the same amount. So that would be our first bit. Well, first bit we did was 12 divided by 3. And you can see the answer is 4. There's going to be 4 in each one. Now, you wouldn't do this in real life because you would just go straight to whatever the answer is, but this is just an example. Okay, so now my answer would look like this. I would have 4, wouldn't I? That would be the answer to 12 divided by 3. So we'll just pop those aside for a moment. We still had all of them there. But now this is our leftover bit here. We've got 4 pieces left, but we still have to divide it by 2 to get our ultimate answer. That was the next step of it, right? So we said, well, now I've only got 4 left, but I divide that by 2, so I put them into 2 equal sets like that. And there is our ultimate answer. So when we divide 12 by 6, we get 2. Now, obviously, like I said before, you wouldn't do this for simple numbers. You would do it for more complex ones, but the principle is the same, of splitting the number that you're dividing by into its factors to make it an easier problem to solve. Okay guys, this one is possibly going to be a bit more of a challenge because it's more about having a good guess to begin with than it is about absolutely nailing down every single part of it perfectly. This is why it can be tricky for some people, but please don't worry, give it a go. It's a good mathematics challenge, and I hope you get to enjoy it as well. So, as we did with the 11s and 12s, we have to deal with 2 digits at once. Obviously 19 is never going to fit into just a single digit here, but it might fit into 86. Now you'll notice 19 is sort of close to 20. So looking at 86, I can think, oh, I could fit easily 4 20s into there. So I'm going to fit 4 19s. So my first guess is that this is going to be 4. Can I prove that? Yes, I can. All I have to do is add up to a number that's less than that, and the remainder is also less than 19. So let's try it out. I can use my working over here. So I'm going to use my standard form algorithm like this. I want to go 19 by 4. I want to check that it's right. So 4 9s are 36. 3 there. 4 times 1 is 4 plus 3, 76, right? I get 76. So it does fit in there, and the difference is only 10, a long way from 19. Now, here's where things are going to differ from what I usually show you. This is how people normally do long division, right? And the reason I'm going to show you like this is because it's just that little bit easier to keep track of in this case. You could potentially just do it the way we normally do and cram it in there, but the numbers get a wee bit bigger, so in this case I'm not going to. So here's what you do next. You subtract this 76 that you figured out, same sort of thing that we normally do, from 86. In this case it gives us 10, not much to work out there, and then we drop this little guy down here to make it 106. The same as we would if we snuck it into up there to make it 106. Same process again. Now, my guesstimation. How many times is 19 going to fit into 106? Same thing again. 19 is almost 20. I could easily fit 5 20s into 100, right? It seems like 5 would be a good one. So, again, we'll do a bit of multiplication over here just to make sure we're on the right track. 9 5s is 45, 5 goes down there, 4 goes up there, 5 plus 4 is 9, 95. That makes sense. Just under 100. The difference is way less than 19. Okay, so I'm going to subtract 95 from that number. 6 take away 5 is 1. Then 10 take away 9 is also 1. And this guy falls from the sky and drops down into here. Now, we've already done a bit of guesstimation on this one. 95 gives us, well, one thing I should have been doing is writing these numbers up here. So this one would go up there to 4. Get rid of that. And then this 5 goes here. That's something important to keep track of. We know that we can easily fit 5 into 106, in fact 95. I'm going to say, I wonder if we can get 6 into 114. It feels like we can, because there's 5 to 100, and then, yeah, okay, let's try it out. Let's double check our math. So same again, we'll go 19 times 6. It feels good, right? 9 times 6 is 54, the 4 goes down there, 5 up there, 6 1, 6 plus 5, 114. So it's going to fit in exactly 6 times. So 8,664 divided by 19 is 456. How about that, guys? So as you can see, there's quite a lot of extra working out, but if you can estimate a number that is close to what you want, it helps you figure out and helps you take your first guess, your first estimation to get you in the ballpark. Once you think you're about right, you can multiply to check and see if your numbers fit in there. 19 isn't too bad because it is close to 20, but it can work for any prime number. The good news is most of the numbers that you'll come across are probably not primes. Any even number, for example, except for 2, which is easy to divide by anyway, is a non-prime, and so you can instantly divide it by 2 or 4 or 6 or 8 depending, and so there's a lot of scope for you to use any of those strategies. So going back to an earlier part of the video, you would select what kind of number it is depending, and that would inform you on what strategy is going to work the best for you. I hope this is a little bit helpful, guys. For my maths kids, it's probably a little bit beyond what you've been used to, but some of you like a challenge, and so here it is. Well done, guys. Thank you for listening.